Did you have any particular questions on the exam stuff that you wanted to go over, or just coming in because office hours?
Not about the exam per se, but it's more on the final project.
Oh, okay.
Yes, I've been more worried about that to be honest than the exam.
All right. So
Yeah.
yeah, what things did you have about the project?
Okay, so now I have some. I know what questions to ask this
Okay,
time.
cool.
For the clock, I want to make it so that because I know that I'm going to need to make my own clock that's like more that the human eye can see at the very least. Because I know as for our game, I'm able to make multiple rectangles now. Thank you very much for that.
Yep.
Um, I would need at each pass to iterate through one rectangle at a time. So I was trying to make my own counter, but I suppose I'm not getting um how to pass it in as like a as an input for my module here for video gen.
So each rectangle is going to need some sort of input, which dictates its color. Yes.
Yes.
So first, tell me what ideas or what you want to happen visually. What do you expect to happen? Like, explain the process to me.
Okay. So imagine for the first three rectangles, they're they have their color, but they're not as high opacity. That's how I will show that um they will get a their opacity will be more clear
Okay.
if they're not selected. However, if they are selected, then their opacity will be full, so that their color will pop out more. That's what I thought like it would look like for the colors to like iterate.
Okay.
Yes. Um. hmm. I sent you a picture.
Let's see. I don't have the picture. I have the picture of like the boxes, not with colors though. But yeah,
But
I have
yes,
the
I'll
picture.
send you. Okay. I'm gonna send you another picture.
Okay.
I'm working out on the details of the rectangle itself. However, I'm just trying to get um
Okay.
yes. Okay. So right now I'm only doing four just to like find the working dimensions for our game.
Right.
However, so at the green rectangle, I want it so that at each clock cycle or my own clock cycle is going to iterate from the green rectangle to the second rectangle to the third rectangle to the fourth rectangle type of thing.
On every clock cycle.
Yes, I was thinking of but not as in like the clock cycle. I was thinking of making my of using like creating like a counter type of thing, right?
Yeah.
So that
So that if the counter is
I
like 0, the first thing is
mhm.
going to be more brightly lit, and the rest are going to be dim, and then so
Yes.
on. Okay.
Yes.
Um. So when you're generating the rectangles, the output of the rectgen module is just like a single bit value, yeah?
Yes.
And that bit value you use in combinational logic inside the VGA module to determine its color? Is that correct?
Yes.
So all you'd have to do is edit that combinational logic and just say, wherever it is, like, on some of the lines, you're going to have something that says, like, if first box true, which is to say that you're within the first box, then color green. Instead of doing just that, you can say if first box true and um, counter equal 0, then it's green. Else, it's dim green. And then you just do that for all the boxes.
I see. And then to create that counter for myself, I would um so in our module VGA, we have our clock, the clock from the DEO board. And so I was thinking of I tried to make a 32 um thing with the formula that we had, which was like the f old over 2 to the to n.
Why do you need
Uh,
the 32-bit counter for that? Or what were you using the 32-bit counter for? Or 32-bit register, I
to
guess.
sorry, to lower the hertz.
Yeah, but like for what purpose? What do you need to lower the frequency for?
Oh, so that the colors aren't going to like be speedy, like so that it doesn't like iterate like so fast.
Okay, I think I'm misinterpreting what the purpose of the counter is. So for the counter, that's not the. I originally thought that the counter was supposed to be the person, like simulating a person going through each of the boxes. But what you're saying is
Oh,
that's the game behavior, that it just
uh,
constantly is having the boxes
yes,
move.
yes.
Okay. Yeah, yeah. So you would have to create a. It doesn't have to be 32 bits, but that's the example you probably used in class. And what frequency do you want the boxes to go at?
Um, that I don't know. What is like a? That's something I was gonna work around with. I just thought that maybe by going through maybe, like, by going by hertz, I'll see how fast or slow the iteration will be, and then I'll mess around with that.
Yeah.
But I don't really know. Yeah.
Okay. Well, I was just curious, like, how fast you want it to go, like, not in terms of hertz, but in terms of, like, um,
Oh, I see. Okay, then I want it to be at the very base of it. At the very beginning of the game, it's going to be the base speed is going to be like normal difficulty type of thing, and
okay.
then um, as they keep getting the lights correct, then it starts to increase in speed.
Okay. Okay.
Yes.
So, so you'd want to make, not only would you want to make it a, what's it called? Not only would you want it to be a counter that's slower, but you want to be able to ramp that counter up, depending
Yes,
on what
exactly.
stage you're on. Okay, so you're gonna need some sort of way to configure the speed of the clock. Um, I don't want to give away exactly how to do that, but I'll leave it at that. You're gonna want to come up with a way to, instead of, and there are a few ways to do it. You can have one clock generator, which you can then configure with different inputs to generate different frequencies, or you can make multiple clocks. But if you have like 10 different levels, it might be a little inefficient to make 10 different clock generators instead of using
Yeah.
one to that you can switch between different frequencies. So that just depends on how you want to implement it.
Yeah. I was
Okay.
thinking of doing something like just one instance of my game clock, and then just being able to ramp that up. However, but that's where the challenge is, I suppose.
Right. Uh, well, I'll let you think about that. But what was the original question you were asking me before I asked those side questions?
Uh, I suppose it was about the clock itself and how I was going to be able to implement it, because right now what I have is I have my always flip flop, my pause edge clock, and then pause edge reset, which is just a default that they gave us for our VGA.SV. And so I thought that I would just be able to create an internal logic, and that's 32 bits, and then um, I would just be able to do game clock, non-block, game clock plus 32, um, 32 bits of one, so like plus one, I suppose. And then I would send that I would send that as an input for my video gen.
And VideoGen is which module?
It's
That's the one that makes the
it,
rectangles. Is that right?
yes, that's where I guess the video was getting generated.
That process sounds correct. Um, I guess my question is, why are you? It doesn't really matter, but why are you making that specifically inside the VGA? Why can't you just make an external module as like a counter and then instantiate it inside of the video gen or something?
My thought process was because the VGA already had the input logic clock, I wouldn't need to like. Is it like if I say input logic clock, then I would be able to use the systems like the board's clock, or I don't really understand how that worked, like
Yeah.
with the wrapper
So
file.
so the VGA module itself has the board clock, right?
Yes.
So right when you use the wrapper module, it's basically just saying here are all of the pins that you want, and then where am I connecting that on the FPGA? And so, it is going to connect your 50 megahertz clock to your VGA module, and then if you instantiate something in the VGA module, that thing can use the clock because the clock is present in the VGA module. So anything you make inside the VGA module has access to the clock signal. And so yeah, you could make it in there, or you could make an external module, instantiate it in the VGA, and then feed the clock to that instantiation.
And then that's where I would create my counter.
Yeah,
Oh, I see. Okay. I was kind of just iffy on how like it gets wrapped, and I saw that the VGA, the VGA module had its own output VGA clock. I thought I could kind of create that same type of logic, but without messing up the parameters inside that VGA by creating an internal.
you're not messing anything up in the VGA. If you're making new signals and just like using inputs, you're not like changing any of the outputs you currently had in there. It's not going to affect anything. It doesn't change anything else. It's just adding extra new logic.
I see.
Um, what else was I going to say? Oh, it can be helpful sometimes to draw out exactly what it is you're looking at, because then it becomes more obvious where things come from, as opposed to looking at your code. So drawing out schematics can help you with that too.
I see.
Um, did you have any other questions on that?
Um, right now I'm just thinking of what you said. So I don't know if I do have questions.
Yeah, you're good. No worries.
Thank you.
Uh-huh.
Do you have any recommendations for like System Verilog books as like for resources?
I don't know about any books besides your textbook. I do know. I can't remember the exact name. I'm going to see if I can look it up. What's it called? I think that's the one. No, that's not it. Oh, damn. Okay, well, there's this one website. I don't remember what it's called. I'm gonna have to look it up. You can message me later and ask me for it later too if I can't find it right now. There's this website where you can actually basically do tutorials on System Verilog. Specifically, like you can type in stuff and it'll check it for you for specific examples. Just I don't remember the damn website name. Hmm. Mm. Damn. Okay, well, whatever. I'll see if I can find it later and I can send it to you. But there is a website where you can look that stuff up and run your own code with like specific example questions that they ask from you. But what in particular is it that you find difficult in System Verilog? that makes you bring that up? Do you want it as just like a reference, or are there specific things you're having difficulty coding up?
Um, I suppose it's the entire environment that is provided for us with like the Quartus Model Sim. I feel as though there's like a lot of things to learn with that, just because, you
Yes.
know, if I'm programming like C or whatever, I just need a text editor and a compiler.
Yeah.
Yeah,
Yes.
I mean
Learning
the
your
computer,
tools
but
is
I don't really
quite a
mess
bit
with it.
of the process.
Yes.
Um, for the tools themselves, I mean, really, you just have to look up YouTube videos, or like for Quartus, you could look up on Intel their tutorials if they do have tutorials that go over how to use Quartus. Are there any specific things in the tools that you're having trouble using, or is it just you feel like you don't really know a whole lot about them?
Yeah, just I don't feel like I know a whole lot about them.
Well, I mean, you could always like just try and experiment with them, like mess around with the different settings and just see what things happen. But in terms of stuff that is important for your designs, um, you already know all the basic things you need for model sim. All that stuff is, for the most part, what you already know. Just knowing how to put code into it and run a test bench on something. As for Quartus, again, you know the bare minimum of the stuff you need for your project. Extra stuff that would be helpful would be things like the timing analysis. So, depending on how fast your clock is, well, you guys already have talked about this a lot in lecture, but you have timing constraints, so you have like the setup and hold time constraints that you need to be able to satisfy. And so if your clock frequency is too fast, then your combinational logic is not capable of finishing in time or things like that. And you won't really run into that problem with this FPGA because the clock frequency is 50 megahertz, which isn't that fast. It's not really that fast. So it's not going to be an issue timing analysis wise for you unless you have like super large blocks of combinational logic, but that's probably not going to be the case. And either way, you're going to be running at a slower clock rate anyways, because you're going to, or at least for part of your logic, you're going to be using like a 1 hertz or a 10 hertz clock or something.
Yeah.
It's really bothering me that I can't remember this website. It's very helpful.
If I don't have a board and I still want to practice like System Verilog, like is it just better to go on Model Sim or?
Well, if you don't have a board, you can't really. I mean, you can use Quartus. You can sim stuff on Quartus, but it's just better to use Model Sim since that's what you're used to, anyways.
Yeah.
Let's see. Okay, there we go. I found it. I'll send it to. I'll send the link to you. So this is not like a comprehensive list of every functionality in System Verilog in terms of like how to write stuff. There's lots of stuff that's left out of it, but it's mostly the basics, how to code up small things, and how to approach writing stuff in System Verilog. So you can just look through pretty much any of the circuits, and you can look at what the descriptions are, and you can actually write up code, and it can test it for you, and so you can see exactly how it is that it verifies using a test bench, and you can check your code and things like that. But these aren't particularly complex examples, more like introductions.
I see. Thank you.
Yep. Well, yes, that's the main one. I think there are some other ones, but I can't remember what they are. Did you have any other questions for me?
Um, for now, no. I guess I'll just work on what you recommended.
Yeah, go for it.
Yeah. Did you guys get your grades back for your tests that you took?
Yeah, yeah, we did. You're referring to my midterm with Dr. Harris?
I believe so. Yes.
Yes. Yeah, we got those back. Honestly, I don't remember. I think it was like last week on Monday.
Hmm.
Yeah, sounds about right. We all did pretty solidly. I think everyone got above. I think the average was like a 80 or a 75 or something like that. So pretty
That's
on
good.
par.
Yeah.
And everyone did like around the same range, and it wasn't like wildly different, like the high score versus the low score. So
Hmm.
if you want, I can show you the kinds of questions that were on it, but it's more
Oh yes, please.
it's more electrical stuff than computer engineering stuff. Let's see. So it's mostly like word questions, so it's going to be a little difficult to read it. But if you want, you can take a look at it. I'll try and hold it still. The image here is not part of the. This was not given. This was a drawing. That was the drawing that I had to make for the question.
Mm.
But if you don't understand any of the words, that's fine. I don't really expect you to know what any of those things mean. It's quite a few new things that we've learned in the class.
Hmm.
There's a whole bunch of other ones, like there's a fun one. I mean this. Oh, that's fine. This is another one here. So essentially this class, it's high-speed PCB, which we're learning about what happens if you treat circuits, the wires and circuits, like non-ideal wires, so they don't perfectly conduct voltage and current. They have resistance to them and things like that. So you learn about transmission lines, and we also talk about driving signals between different PCB boards and things. So things like reflections, which occur when you have a transmission line that goes into a mismatched termination resistor, a whole bunch of stuff that is quite a bit to go into, but some pretty interesting stuff. What kinds of questions did you guys have on the midterm?
Okay, so the first one was a comparator. We had to deal with overflow. And then second question. If I remember correctly, it was converting machine RISC-V into machine code.
Okay.
And then we had a counter question. We then had converting machine code into RISC-V.
Okay.
And then we had a high level code turning it into RISC-V machine code.
Right.
And then we had recursion.
Okay.
Yeah, and that was we were kind of like how in the assignment we had to iterate through it, given a set of parameters, and then had to convert that into RISC-V, and then that was it, I believe.
Okay. So it seems like you guys had a decent amount of problems. Did you find that it took you a long time to get through all of them?
I was able to do the first pass I was able to go to the recursion, which is like the final question. But I was only able to go to the first pass of it, not the second pass. So,
Okay.
yeah.
Let's see. If I remember correctly, after this, you guys are going to do a little bit of stuff on different kinds of adders and parallelism and a little bit of microarchitecture. Maybe we'll see if you go into any of that, as well as logic elements and FPGAs. And I think your guys' final is cumulative. Like you can go over pretty much any of the topics from before. So
Yeah.
quite a bit of stuff to study for that.
Mm-hmm.
Mm. When do you know when your guys' next homework is due? Is it next week on Monday or this upcoming week on Monday?
Coming week on Monday, yes.
I didn't even look at it. What was it? Have you seen Have you seen what's on the homework?
No. Oh, we have to make a BCD counter.
Okay, a binary coded decimal counter. That's 1-digit BCD counter, test bench. Okay, so that's some pretty helpful stuff. Okay, yeah. So this is more of like a kind of like a mini project kind of thing where you make a bunch of small modules and then you generate one big larger kind of hierarchical structure composed of those smaller units. So it's a little bit like a mini project, just not nearly as bad as, or not nearly as big
That side?
as
Mm-hmm.
your junior design competition project or as your 200 project. It is going to use a lot of system Verilog stuff, so you might need to review a little bit of that before you get started on it.
Yes.
When does your guys' lab project, like when's the junior design competition?
It's on December. Uh, check. December 8th.
Okay, so you got about 3 weeks until then.
Yes.
Okay, so you got a decent amount of time to work on your projects. You guys aren't doing any other labs, right?
That's what I thought for, last week, but then we got lab 8. So I don't know if we're gonna get more or we're done.
Okay, well,
Yeah.
what's your next lab?
I guess after module 8 is done, actually. Yeah. Module 6 we skipped, so after module 6 is final projects, I guess it's done, right?
Um, yeah, I guess. It also looks like you guys only have like 3 more homeworks
Yes.
for lecture. So nearly done, yeah. It's crazy how fast the semester has gone by.
It has.
Um, you mentioned that you haven't taken any EE classes yet. Do you plan to start those next semester, or?
I went to a academic advisor. And what they recommended for me was CS 302, CPE 300, Math 250, discrete math, and physics 195. So I don't know if I'll go with that or if I should like take an EE class.
You can wait on it. It's fine.
Mhm.
Next semester, I believe Baker's not teaching 220. He's typically one of
On
the
fall, right?
professors that people recommend for 220 because he's pretty good.
Mhm.
And he's going to be doing 220, I believe, because he's doing it right now, like this semester. So in a year's time, next fall, he'll probably be doing 220 again, and that's probably when you'd want to take it.
Okay.
Let's see. Yeah, sorry, I've just been ranting. Did you have any
Oh no.
questions for me?
Oh no, you're fine.
Okay.
Aside from my initial ones, I just been working on on the system Verilog.
Mm-hmm.
Do you know if is CPE 300 required to take?
Yeah, for CPE majors, yes.
Oh, okay.
Yeah.
And then so I would need to take 300, 301, and 302, or is
Correct. You have to take all of them.
oh oh okay.
Yeah. If you were a EE major, those would be optional as electives. That would count towards some credits or something. I know 300 and 302. I don't remember 301 probably as well. But yeah, you're required to take all of those.
Let's see.
Do you know what? Well, I don't. You don't necessarily need to decide this right now. But have you looked into any of the core classes or like the different concentrations?
Yes. There was one about like system architecture, right? Or is that not core class?
So there's 4 concentrations. They'd appear like on your degree sheet. The concentrations are digital design, computer networks, embedded systems, and information systems. The one you're referring to, I think system architecture, that sounds like something that would be in the computer networks concentration. I don't recall. But I guess maybe a more interesting question is, what things have you done so far in your classes that you have enjoyed? Because right now, it's fine to not really have an answer to that because you've gone through some classes and done some projects, but you haven't really gone through that many. You haven't gotten to like the 300 level courses as much.
Yeah.
And the 400 level courses is where you kind of start to get into more project based classes and you can do fun stuff. So like for example, me, I'm doing embedded and digital design as my two concentrations because, uh, well, I like digital design a lot, so that's why I chose that one. And embedded systems was the other thing that I thought would be interesting to work on, which is why I went for those.
Mm.
So do you have an idea of what kinds of things you'd want to do?
I would think maybe embedded system, just because I do like programming a lot.
Mm-hmm.
So that's like where you would be programming in like and C for like small chips, right, and
Yep.
stuff like that.
Yeah, that's right.
Okay, and then so, oh, sorry.
Oh no, yeah, continue.
Oh, sorry. So digital design is like what we've been doing so far with this, and then do we get better at System Verilog for that, or
It depends on the class. So, for
That's the
example,
class?
you're going to be taking CPE 300 next semester, which is processor design and architecture. And one of the core classes for digital design is CPE 404, which is advanced microprocessor architecture, so like CPE 300 Part 2. And you do some System Verilog stuff in it, but it's not necessarily focused on that. It's more focused on learning how a processor is designed and what kinds of things you can do to increase the efficiency of that processor. And you do apply it for a few projects to, like for example, when I took 404, we had one project to make a correlating branch predictor, which is basically just when you take branches in assembly, you could or could not take that. It's possible for you to take the branch or to not take the branch. And oftentimes in programs, branches are taken in a predictable pattern. And so you can create a piece of hardware to predict whether or not you're going to branch. And if you're able to successfully predict a branch, your processor is able to more quickly execute instructions. And because of that, your efficiency increases. And so we created a branch predictor. So that was a fun little project. And then another digital design class, that one that I'm taking right now actually, is EE 421, which is digital integrated circuit design. And for that one, we're learning how to use this industry tool called Cadence to take. Do you know what the little black packaged chips look like that have the little metal prongs sticking out from them? Do you know what the things I'm referring to?
integrated circuits?
Yeah. So you learn how to make those kinds of things. So.
Oh, okay.
So in the past, students were actually able to, for their final project, actually get a chip printed or fabbed and then sent back to them. But they discontinued that, sadly. So it's not happening anymore. But you learn how to basically make a design and implement it in a piece of silicon. So you have this view where you can basically put down like a bunch of rectangles that correspond to different materials and layers in your silicon chip. And then you can create things like transistors and resistors and capacitors, and you can slap all those, combine them all together. You can use, and then the emphasis of this particular class, since it's digital IC design, digital integrated circuit design, is using digital logic. So like creating AND gates and NOR gates, and then using those to do operations and stuff. And so then you can put all of that out. You can lay all those transistors and gates and stuff out, and then now it's in a format that you could send to a chip manufacturer. They could take that, and then they could print out the boards and send it back to you. So it's pretty interesting stuff, at least to me. I think it's pretty interesting. So that's the kind of stuff that you'd see in those core classes, at least for the digital concentration. I don't know too much about the others. I know computer networks. I don't know that much about computer networks, and for information systems, I know that's like IoT, or that's one of the classes. Some IoT.
Oh, Internet
stuff.
of Things?
Yeah.
Okay.
So.
So would computer networks be like Wi-Fi and
I
like that?
don't really know that much about computer networks. I know you could look up some of the classes within that core to get an idea of what it is, but I'm not too sure actually. That's your suggestion seems like that's in the realm, but I don't think it's specifically about Wi-Fi necessarily. I don't actually know.
Oh, I see. I think computer network. So I'm looking at it from Geeks for Geeks, and they said like it's the practice of connecting computers together to enable communication data exchange.
That sounds
So I
about
guess like
right.
the cloud, like the cloud would be computer networking. Yeah.
Uh, yes, but I think I think there's a class on the cloud, but for the information systems instead of computer networks. But I don't know. I don't remember all the classes for those. You know the like for example, CPE 400 is one of the computer networks classes, and it's exactly what you described: how to connect computers together and network them together. Hmm. Well, and there's another one. It's CP 405, which I actually took, but not for the core classes. I took it as a professional elective, um, which was coding theory. And when I say coding theory, I don't mean like C++ coding. I mean like how to encode data into binary efficiently, and the different methods of encoding information depending on what thing it is you're encoding. So the way that you encode raw data is different from the way you encode, like an image, which is different from the way you encode a whole bunch of other things. Um, and so like compression algorithms, like how the zip compression works, things like that. And um, and that was a pretty interesting class, but it's very very much theory based, like almost no hardware really. It's just all theory, but it was pretty interesting.
When you say like compressed zip, like you mean like literal zip files that we have on like
Yeah, yeah,
computers,
yeah.
and then
So like the compression algorithm for a zip file, like how it compresses
mm,
your files, as well as like how uh, an image is compressed when you store it like in JPEG format. Um, because when you have an image, there are there's basically an allowance to degrade the image quality and still have it be recognizable. And so you can be efficient in your encoding by kind of getting rid of any redundancies and basically downscaling the image essentially by the way you store it, but a whole bunch of information on that stuff.
mhm.
Lots of theory in that class though. Did you have any other questions for me?
Um, or embedded systems. Was there like a project? Was there like a project that you really like to do that you really liked when you did it, or
Like in my classes?
yeah?
Well, right now the projects that I'm working on are pretty interesting. The one for the digital IC design class, that one's pretty interesting. We're designing a power supply, a switching buck power supply, and in right now I'm in the PCB class. We're designing a signaling system that would go on a PCB, which is pretty interesting. Um, my I guess my favorite project so far that I've like actually completed was probably the one that I did for 302 for CP 302 because I took CP 302 with Dr. Harris because she taught it that semester, and we got to work on our projects for a decent amount of time. So I made my water reminder, and that was a pretty fun one. Um, but yeah, if you're able to choose your own project, you can make it pretty dang fun.
Mm-hmm. Did you do a project where you had like a crane for like?
Yeah, yeah. For CP 301 for my embedded systems lab,
Mhm.
me and my partner made a claw machine.
Oh yeah.
It was pretty fun, though it was admittedly quite funny because we made the physical structure out of cardboard.
Oh yeah,
And
I remember seeing that.
yeah, that was a pretty funny. Were you there? Were you at the junior design competition?
Yes, I was.
Oh yeah. Yes, we did. We did make the claw machine. That was a very fun one.
Hmm.
Yeah, there were a lot of nice projects there too. I really liked the hex dropper one. That was a pretty cool one.
Hmm.
If you remember that one.
Was that the one where you had the hexadecimal and then you would guess it kind of?
Yep.
Or
Yeah,
yeah.
that's the one.
Mhm.
I thought that one was pretty dang cool. And there were some other pretty cool ones like the Castle Defense one and the Pong game. Those were all pretty cool.
Yeah. It's like I remember the Pong one specifically because I remember I forgot his name. The guy from that came from the guest.
Yes.
He really raved about the Pong one. Yeah.
Yeah, he did. Yeah.
Hmm. And here I am still just trying to figure out how to like move the rectangle.
No, it is a process. You just got to work at it.
Yeah.
Do you want your rectangles to move, or are they supposed to stay in the same spot?
They're gonna stay in the same spot.
Okay, that's fine then.
Yeah.
How do you think you would get them to move if you needed to?
Well, if I was thinking about this in like other programming language, I probably shouldn't be thinking it like that. I probably would need to start thinking about it in the hardware. I would just assume it's like I would just need to just increment it or decrement it because that's kind of like how you get data to move, right? But I guess in terms of hardware, um,
Well, how do you
I
increment
would
or
have.
decrement a value in hardware?
Well, you would just add or subtract, right?
Yeah, specifically, you'd use a counter, right? Either an up counter or down counter, or one that can function as both, depending on if you want to go up or down. Yeah.
I see.
So instead of feeding your rectangle generator modules a constant like 470 by 530, you would instead feed it signals that are outputs of counters. And those counters can be initialized to 500 or whatever, and then you can change them over the course of the runtime of your design. They'll change depending on whatever parameters you care about.
Mhm. I suppose another thing that's like getting me when it comes to some Verilog is that it's parallel compilation, right? Or is that not
Yes.
given to us?
That's correct. Yeah, it's.
Oh, okay.
I think when you say not given to us, you're referring to the fact that when you run stuff on Quartus, it says parallel compilation not available. Something
Yeah.
like that. That's just I think that's just referring to doing multi-core compilation on your processor.
Hmm.
I don't know if that's. I don't know what it actually is. I think that's what it is. But in terms of like code, yeah, the way you write System Verilog, everything's done in parallel. You don't need you don't need to have it sequential like in C++. You can have blocks out of order, and it won't make any difference because they're just blocks
Yeah.
of hardware and interconnects between those blocks.
I suppose as I'm thinking about it now, like it's the bits that we set isn't really too difficult of a concept to grasp. It's like we're just giving it like our range, you know. Because taking a look at for x and y, I was kind of confused on how I could use that to like move my rectangle, and then I suppose I could just like use combinational block to. Because I was taking a look at how they did it for the generate rectangle, which is x is less than or equal to the left, and then that signal needs to be is ended with the x is less than right
Yeah.
to generate that rectangle. But it really is just like in decimal, it would be like from 0 all the way up to like whatever parameters.
Yep.
Yeah.
Yeah, and if you want to, you can attempt to create non-rectangle objects. So using bitmaps, you can put like a, like an 8-bit character model or something like that instead of just a rectangle. So using bitmaps would be the next step after learning how to use rectangles and manipulate them. So there's a little bit of a learning curve to doing all that stuff, and it is quite a bit to figure out. Kind of when I was working on it myself, I was banging my head against a wall for more than a few days trying to figure this stuff out. But once I figured it out, it made a lot of sense, and it felt very gratifying to actually figure it out. Do you have any other exams coming up soon?
I have a math test next Tuesday, so I gotta study for that.
Is that for Calc 2?
Yes, Calc 2.
What are you guys going over in Calc?
So we just finished. So we're continuing off of our Taylor and Maclaurin series, and then we're going to chapter 9, which is that's the one with like x of t and y of t. I forgot what it's called.
Like parameterized.
Parameterized, yeah.
Yeah.
And that's what it's gonna cover on.
That's what you guys are going to cover for the last little bit.
Yes. For our test, yeah.
I almost said parameterized modules because I've been thinking too much CPE, but it's not.
I was thinking that.
Parameterized functions. Has your partner started to work on, like, for your lab project, have you and your partner decided on like who's working on what modules and things like that?
Well, right now we're me and her have just been talking more about how to do like just the rectangle stuff, and then I suppose we can. I suppose she wants to work on the counter stuff. I just came to ask about it.
Oh, okay.
Yeah.
So, what is it you plan to do for the user inputs? You're gonna have a rectangle which is like moving, quote unquote, on the screen, and then you're gonna have their rectangle to like select a rectangle. Is that right?
Okay. So imagine that the fourth rectangle is going to be like fully bright, essentially, because I'm gonna need to create like a random number module, and so each rectangle is like assigned 1, 2, 3, 4, and then if that random rectangle module is on, then it's going to output like a brighter rectangle, and then starting from rectangle 1, the user needs to match that rectangle with the brightly dimmed or the brightly lit rectangle, and then they just have to press a push button. And if it matches, then they get a point. If they don't, then they don't get a point.
Okay.
Yeah.
Well, you'll run into these things a little bit later, but just make sure to consider your push button debouncing, because when you press your push button, you can possibly get like a very quick oscillation of multiple presses because of the spring kind of jittering up and down, and you'll have to debounce that button in order to read in one clean button press into your system. So you'll have to consider that later.
We were thinking of using like the GPIO pins to connect like a external push button, but the ones that they had in the where they give out materials and stuff in the electrical engineering thing.
Yeah, the stockroom.
The stockroom, yeah, they didn't really have any big ones. Like they wanted like at least like a decently sized one, but there wasn't really any. They were smaller than the DEO board.
I see.
Mhm.
Yeah, I mean that sounds about right. You could make your own switches if you wanted to, but I would just use the ones that are already on the FPGA to make your life easy. You could always change it later.
Yeah, that's just want to make sure that the core functionality works, and then
Exactly.
if there's time, then add
in
some
the
stuff
extra
to make it
stuff.
pretty.
If you feel
Yeah.
like flexing on your competition, absolutely go for
Mhm.
that. But get something to work first. That's the very first step.
Oh, for sure.
All right. Did you have any other questions for me before I end my office hours?
No more questions. Thank you very much.
Yeah, you're very welcome. All right. So yeah, you have a good one.
Thank you. You as well.